Hi, everybody. Welcome to the PC Perspective Podcast. This is episode 190, recorded on February 22nd, 2012. I'm Ryan Shrout.
I'm Jeremy Hellstrom.
I'm Josh Walrath.
And I'm Alan Malventano.
And if you're watching the video version, you can see things have changed behind me. We are kind of at this halfway between point in moving offices and setting up new sets. This is not the new set. This is just the TV that we haven't put behind us with R2-D2 Mickey Mouse ears to try to spruce things up a little. But we're going to do our normal podcast, doing everything like we normally would do. If you want to share this show with everybody, and obviously you should send everybody to pcper.com/podcast. And then if you want to know about the stories we're going to talk about, before we talk about them, all you have to do is either read the website every day, which I highly encourage that, or go to twitter.com/pcper, facebook.com/pcper. The other one is Google+, gplus.to/PCPer. We post all of our stories there, so if you get notifications about new reviews or important news items, you will see them there as well. Now, we've got a lot of stuff to talk about this week according to the show notes, so let's jump right into it. First thing I want to point you guys to is this. We have a awesome contest going now with our friends at Intel and PC Audio Labs. If you've never heard of PC Audio Labs, they make PCs kind of dedicated and designed specifically for audio creation. So if you make music on your guitar, you do DJ work, you do anything like that, they make systems specifically built for you with software packages specifically built for you. Even better is if you're not interested in paying for one just yet, you can win one for free. All you have to do is go to pcper.com/contest. Easy, simple URL, and you can win one of these systems from PC Audio Labs and Intel. What the hardware inside is a Core i7-3820 processor, X79 motherboard from Intel as well, 16 gigs of Kingston DDR3 memory, an Intel 250 gig 510 SSD, and Asus GeForce GTX 560 Ti Direct CU2 graphics card, and an Antec 850 watt power supply. There are other specs too. You get two 1 terabyte hard drives. We did a video that kind of shows you an overview of inside the system, the software you get. Total, we're talking about $3,600 in hardware and software included in this. And really, to enter it, it's about as simple as it gets. You have to go to facebook.com/PC Audio Labs and like their page, leave a comment if you want, thanking them for supporting PC Perspective, and then leave a comment on our news post at pcper.com/contest and tell us what you want to do with this system. What do you currently do that would make it easier with a system with this much power? What audio creation projects are you working on that this might help with as well? So check that out, pcper.com/contest. And yeah, everybody likes free stuff. Sorry, you guys on the podcast, you can't enter if that wasn't already up. I know, it's disappointing. A couple of other quick things we're going to talk about. One is a quick editorial. Actually, looks like I opened up the wrong thing there. We looked at how to review a notebook, how we review notebooks, rather. Matt Smith specifically goes over the metrics he uses, the software he uses, the benchmarks and tests that he uses when comparing notebooks, when comparing laptops to each other. It's not like an editorial in the standard sense. He's not making declarations about specific products, but it's a good bit of information to have when you come to PC Perspective and you look at our notebook reviews. It's always helpful to have something to go back on and see how these different systems are being evaluated, and then he's going to obviously refer back to this in all of his upcoming notebook reviews as well. So if you're curious about our testing process for notebooks, check that out. The next story up is actually an interview that Josh had via email, I assume, with MSI.
Yeah, because nobody talks to me in real life for obvious reasons.
You're right, so I can completely understand that. So it was with Alex at MSI. Was it specifically about their graphics division here? What all did you guys talk about, and what maybe came out of the discussion that was interesting?
Well, I was able to ask him a few questions about the graphics department. He was formerly in charge of that until Rajiv moved on to greener pastures, and now he's in charge of motherboards and graphics cards. So he's kind of a marketing manager for that. And so we have reviewed quite a few MSI video cards in the past year, and they've always seemed to impress me. I don't know how you feel about them.
Yeah, no, actually, they've made a lot of great strides in graphics. You know, with the Lightning series and that kind of stuff, they've really done a good job. You know, aftermarket coolers, they've spent a lot of time. They're not just throwing on something out of the box and sending them out for reviews.
Yeah, and so I mean, you know, I looked a little bit back on about 10 or 15 years ago when they first came into the video card market, and back then, like around the GeForce 4 time, what they did is they had the reference card, but then they had, you know, an absolutely amazing bundle. I remember getting one of the cards in, and they bundled seriously 8 really, really good games, like No One Lives Forever, or what is that? What was that spy game in the early 2000s with the woman?
That sounds like it.
Yeah, No One Lives Forever. And, you know, like Sacrifice, some of these other really top-end titles, and plus video editing software, all kinds of stuff. And they've kind of gone from that to where we are now, which is higher quality PCBs, higher quality components, and fans and heat sinks that really do their job very, very well. And so we talked about things like, you know, are you looking into vapor chambers with some of your Twin Frozer series, or are heat pipes pretty much, you know, where you're looking at? And he answers quite a few questions there. I mean, it's some interesting information. It seems like there will be a Twin Frozer 4 series coming out eventually. We don't know if this is going to be with the latest Lightning series with the next generation of graphics. He talked about how long it takes to design some of these you know, Lightning series and you know, some of the higher end PCBs and products. While, for example, I mean, they can take the reference design and change around their heatsink and their cooling system so it can be a Twin Frozer 3 product. And they can do that very, very quickly. I think 2 weeks passed, and MSI was able to offer a Twin Frozer 3 based 7950 product that I think that you got there. And so we just talked about product cycles, what all they're doing for it, what are the things that they're really concentrating on. And, you know, MSI is I mean, they're kind of at the top of the game right now. And, I mean, they're competing very, very well with Asus. And we went into some market share numbers. I mean, they didn't give me actual numbers. But, you know, they're number 1, number 2 in the North American market right now in certain categories. So this was a big step up for MSI, especially when going against the giant that's called Asus. Now that we've had like BFG fold up and you know, some limited interest in going into the North American market, they're really capitalizing on it, and they're doing very, very well. So it was a nice interview. It would be good to read the entire thing. He goes into a lot more stuff than I can cover here. And, you know, they're on the fast track to being one of the top graphics manufacturers, at least in this market, if not the world.
Very cool. Another review that we'll mention very quickly, actually kind of as a follow-up to the How We Review Laptop story. Matt Smith actually did a review of the Lenovo ThinkPad T420, which is, he calls kicking it old school. It is very much, it's not an Ultrabook. You can tell from the photos, it's very much kind of like a business-centric type of design, which isn't necessarily a bad thing if that's what you're looking for. The specifications, Core i5 2520, 2.5 gigahertz. It does have discrete NVIDIA 420M, 4 gigs of memory, 500 gig hard drive, 14-inch, 1600 by 900 resolution screen, which is decent. It comes with a 6-cell battery standard, 9-cell optional. It does not have USB 3.0.
No, there's no
yet.
USB 3, which seems a little odd, but
yeah. 720p webcam, 4.9 pounds. So, you know, we know that how the performance works. We know kind of what to expect there. Lenovo keyboards. If you like Lenovo, you already know why you like Lenovo. I am attached. I love my Lenovo X201. I bought 2 of them right after the first one was kind of old and outdated. I made sure to go get a second one because I was so happy with the form factor, the battery life, the durability of these machines. The main selling point for me is if we look at the battery life benchmark, you'll see with a 9-cell battery, he's getting as much as 9 hours and 53 minutes on the reader test, which is, I believe that's Wi-Fi on still. You have to check that article about how we test laptops. But I think that's Wi-Fi on and just basically reading web pages, that type of thing. So very simple, but also great to see that you're getting almost 10 hours of battery life on a single battery, a 9-cell battery. He was impressed enough with it to give it an editor's choice, which he doesn't actually do very often. Performance is kind of where you'd expect. It's right up there since it is based on the Core i5 Sandy Bridge processor. And if we look at gaming, not so much. It does decent. It's got NVIDIA Optimus. You'll be able to get discrete graphics performance, at least some benefit of that without losing any of the battery performance, which is nice. And it kind of goes against the HP Elite books, the Latitude, that kind of stuff. But he obviously was pretty impressed with it to give it the editor's choice. So if you are interested in something that's maybe not as sleek and as cool looking as an Ultrabook like Alan has, or like a MacBook Air, but you want something that's durable, or something that's going to be able to take a beating while still being functional and useful, then you should check out that Lenovo T420. Okay. Maybe one of our bigger stories of the week was actually a kind of a combination here. A story that came out earlier in the week from several, I guess, a researcher, school, Microsoft, talking about kind of the downsides of NAND flash, the SSD in particular, and how they predicted basically by 2024 SSDs would not be beneficial when compared to standard hard drives. Is that right? Was it 2024? Was it that far out, Alan?
Somewhere out there.
So, Alan, give us a little feedback on what their story was, and then what your thoughts are on that. Right? So, I mean, you disagreed, but tell us a little bit about what they were saying and why.
Yeah, I'll give you the quick rundown of what the paper was focused on. Came out, I think it was mid to late last week, actually. And then over the weekend, this was picked up by 7 or 8 of the bigger news, outlets online, like PC World and the Register and stuff like that. But basically, there was a group from University of California, and it looked like in combination with Microsoft Research in Mountain View. And the paper is titled "The Bleak Future of NAND Flash Memory," and the focus of the paper is pretty much just that, is to make that argument. And the first part of the paper goes through and talks about how triple level cell and even like higher than in different numbers of voltage states per cell. Like if you try to increase that, that's bad, really. Like it makes the longevity of flash go down. It makes the endurance go down. It takes much longer to program, that sort of thing. And then the second half of the paper says, okay, well, let's just try to figure out what happens as we do die shrinks and move forward. So they're just trying to, see into the future what's going to happen with flash memory. And they're actually very accurate, just to I guess start it on a good note for them. It's very, very accurate on what their mechanism to their calculations to figure out, okay, what happens, and I'll caveat this with the given process technology, if they just keep shrinking the dies and, making the feature size smaller and smaller, just, smaller process nodes, moving forward, what is theoretically going to happen, right? Once they get down to this, 10 nanometer, 8 nanometer, like once they go even smaller and smaller on the processes.
6 nanometer will be the end of the world. End of the world.
Well, but here's the catch, though. They make some really, I don't know, just there's like a big slant throughout this whole thing. There's that, it's wrapped around this nice part about how die shrinks, the negative effects of die shrinks and everything. But just think back to all the CPU articles you've seen over the years, the ones that are like, oh, the world, the end is 9 for this process.
We'll never crack that 1 micron number.
Yeah, we'll never get smaller than this because of, insert laundry list of reasons, right? And then what happens 6 months later? Somebody announces something, right? Because the manufacturers, it was when it was at, 1 micron or whatever you want to call it, right? Whenever it was at that feature size of that time in the long past, it worked at the time, right? People were buying those parts. They functioned properly. And then the only time the manufacturers really overcame the hurdle was when the need really came up. That's when they figured out, they spent the extra effort, figured out this new thing. Or maybe they had something in their back pocket and they busted it out and, things kept, advancing. But
I got something in my back pocket.
Mm-hmm.
Yeah.
Doesn't need advancing.
Let me get up and show you.
Oh Jesus. So the second, the second like 2/3 of this paper, after going down the whole triple level cell thing, which, by the way, triple level cell is not this huge push, right? It's of course that's doomed to failure probably because nobody really cares about that. Nobody's trying to go higher than multi-level cell for consumer grade and even enterprise class devices. So first argument in the article, sort of like to anybody that understands what they're talking about with it, is
why are they not looking to go to a little TLC?
Yeah, I know, right? As a matter of fact, they slanted so hard on the TLC thing that their first graph that actually Burke was just showing on the stream, the data points that they gathered for different types of flash memory as the feature size shrinks, they only looked at what appears to be 25 nanometer, only looked at TLC for that. So that right there also is just this big glaring outlier in the article. Like there's, I don't know, like 90% of shipping flash memory devices right now are 25 nanometer MLC. So why would you skip that data point? That would seem kind of important to include in something like this that's trying to predict a bleak future, right? So moving on to the whole, second 2/3 of the piece, they figure out, okay, where do all these die shrinks correlate to moving forward in the industry? But the problem is that they wrap that around an assumption of a prototypical solid-state device that has a fixed number of flash memory dies. So imagine you have so if you have this board that only has, so here's an SSD, it only has this many chips inside of it. And actually realize that, but realize that the number of dies is actually variable within the number of packages. So if you have an X number of chips on a device, they actually stack the dies to different heights within those packages.
So if you got a big package...
Oh, Jesus, Josh.
You can...
Okay, so they assume this model of a fixed number of dies, which all you have to do is look around you and see, I even included a picture in the article, people are scaling these things up, right? They're putting, OCZ makes an R4 that has it's in the 100 count of packages. It's not even die count, that was package count, right? And it ended up adding up to 1.6 terabytes. Just because they scaled it larger, Josh is losing it over there. Just because they scaled it up and just included, more TSOPs, more packages with dies in them, right? So they make this assumption and then they say, okay, look, here's why the future's doomed, because we're going to assume that your controller can only ever talk to this many flash chips, this many actual dies, and given the shrinks, you're just going to hit a brick wall eventually at some point. So, yeah, they're right, but their presumption, their whole the basis they wrapped it all around right from the get-go is just steering it the wrong way. It's a bad assumption to make. So really, the paper just sort of has this underlying slant to it, and I think it's because those same guys they dabble in other research into other solid-state technology that's alternative to flash, like phase change, the magnetic stuff that's on the horizon, those other things. So I think and don't get me wrong, I like anything that's a solid-state technology that's going to work well and whatnot, but if you write a paper like this and you slant it so far, there are people that are going to see the holes, and they're going to point them out. So I decided I was going to be that guy this time and point those things out in our piece. But yeah, it's just really, really crazy because they left out. I don't even think they addressed at all any advancements that might come during while these dies are being shrunk for flash memory. Right? They basically assume that you're just doing nothing but shrinking it. And you're not making any other. Think back to CPU technology like strained silicon and all those other advancements that came out. The new 3D FETs that's coming out and the Intel architecture, things that are going to make these huge advancements, right? Heck, you could take that same 3D technology and you could roll it over into flash memory technology, and you could potentially make smaller feature size, but you can have a bigger quote unquote like bucket where you're storing your charge, right? If you take where you're storing your charge, instead of having it flat, you actually make it vertical. You can have a much bigger place to store the charge, so you're not so worried about it drifting over time. That sort of thing, right? There's all kinds of other advancements that can be made in the chemistry of what makes the insulator on either side of the gate, which actually holds, the part of it that actually holds the bits, holds the charge, to make it last longer. That sort of thing. There's just, and I'm just like throwing things off the top of my head just from what we know is already out, but just hasn't been applied to flash memory yet because, again, there's no need yet, right? Intel's making solid-state drives that they can warranty for 5 years. That's good enough for a product that you sell, right? You don't need to they don't need to make the longevity any higher than it is right now. And for the things moving forward, like 20 nanometer, Intel has been making 20 nanometer since last year. They're not shipping it in products yet. Why? They haven't refined their process well enough to justify the endurance being long enough and all those sorts of things. So when it's ready, when it's good enough, they'll ship it in consumer products, and even when it gets even better, and they can apply some of their high endurance technology and other stuff to that smaller node, they'll probably ship that for enterprise too. So yeah, just basically all those things. And
The sky
what
is
really
falling.
kills me.
The end is near.
Oh my God! Yeah, the end is near. What's really weird is that the article makes that assumption on constant die count, and they're actually using like a relatively small number constant die count. And then they talk about how it would be really hard to get to the terabyte range, or once you get up to like 14 terabytes for a flash drive, it's going to be too slow, and the process will be too small, and it won't endure long enough.
And your drive will last
things.
5 minutes after you bought it.
Right, basically. And they're not bringing up that just the simple fact that every time you double the size of a solid-state drive, if the endurance was cut in half, it would last, on average, the same amount of time, right? Because if you're writing to it at the same rate.
That sounds like a really bad joke.
Nah, I don't know.
Yeah,
don't want to
maybe.
Yeah.
But yeah, I mean, there's OCZs can scale a current product, that R4 cloud server that just came out. They can scale that guy up to 16 terabytes right now if they want to. It would cost a lot of money, but they can do it, right? So, it's again, they can do that because they're not restricting themselves to a quote unquote constant die count. So they can already make a solid state device at 16 terabytes, and that's with 25 nanometer. That's with what we've got right now. So,
And besides, with all the cumulative write errors and read errors off of large arrays of hard disks, I mean, they were saying, multi-terabyte arrays are going to start failing immediately because, sooner or later all those little bets are going to add up and kill it.
right,
Not
and
so much that I've
and so
noticed.
Here's what's so funny. How has the hard drive industry gotten around that? There's this thing called RAID that has parity that's distributed amongst the drives, right? So all you do is you make a controller technology that once you get to your threshold of pain on how far you want to spread those bits out over, a large pool of flash where one chip could go down and you could be dead in the water. Well, you just add some redundancy to the system, so you can have one chip completely fail.
Sky ain't falling.
then-
It's a rainy day, but the sky isn't falling.
Yeah, and not only that, but the rain's not coming for like 8 or 10 years or something.
Yeah.
This is.
And if you haven't
flash
upgraded
memory.
by that point, you're just begging for it.
When you think about shipping like volume flash memory, where people were actually paying attention to it and putting it in devices that were in their computers that they were using as like primary storage, this is only on the third generation, right? It was 50, 34, and this is 25 nanometers. So we got a ways to go here. people. it's not doomed just yet.
That's good news.
It's not dead
I
yet.
like SSDs, and I don't want them to die and go away. Just a personal thing. Hey, real quick, do you guys remember variable SMP on the NVIDIA Tegra 3 SoC? Anybody? You guys remember that? The fifth core? It was a quad core.
Okay. Yeah.
It was a quad
the companion core.
Companion core.
Yeah.
You remember it was called variable
What's that-
SMP,
what's
but you
the
don't
thing
remember
for?
that. It's not called that anymore. It's not VSMP anymore. I just got an email. NVIDIA is changing the name of it to, get this, 4+1. The number 4, the
Wow.
word plus,
Josh.
and 1.
Go ahead, Josh. You're on. Insert Josh.
Wow,
joke now.
my mind is blown by that. I keep wanting to go back to SSDs and say, when my wife wants me to walk twice as fast, the trip lasts half as long.
Mm.
Let's not go there.
Eh. So NVIDIA renamed VSMP as 4+1. The reason, according to this email and this blog post, is the more popular this technology became, the more our customers wanted a name for it that's unique and descriptive, a name they could put on a box and store, or a store sign, and immediately represent its value.
They still still went with companion core.
I liked VSMP, and now that they've called it 4+1. I don't.
Companion core is good. You'd have the core there, and you'd have a little heart in the middle of it, and you can carry it around with you. It'd be great.
They should have etched it onto the package. They should have
You're
etched
right.
the little
Yeah.
companion
Maybe they
cube
did,
thing.
and we'll just never know. 4+1. NVIDIA Tegra 3 with 4+1 technology. It doesn't even... Just, never mind. We'll move on. Actually, we're going to move on and take a break and thank today's podcast sponsor, and then we'll get back to a glut of news from the past week. All right, thank you for that. Let's talk about, we like getting things for free. PC games, we're all PC gamers. We like to get PC games for free. Now, on February 16th, there was an announcement that Mass Effect 3 is on its way. Everybody knows, Mass Effect, great game, great series. If you pre-ordered it, you would get Battlefield 3 for free. For free, Josh says?
For
Yes.
free? Must be pretty good if they're offering it for free.
Yeah.
So the problem is you had to pre-order Mass Effect 3 through the Origin store for any platform, including digital download box, PC, Xbox 360, or PlayStation 3, before March 5th. Hey, Josh, what's today?
It would be March 22nd? No, February 22nd.
Right, it's February 22nd, which is before March 5th. Well, apparently, 2 days ago, EA just puts out a tweet on their message that says, hey, sorry, that deal's not any good anymore. So if you didn't take advantage of it immediately, you apparently missed out, because in EA's mind, digital copies have limited availability, much like Star Wars The Old Republic had a limited number of special edition digital download copies.
Their distribution server was running on that flash memory.
Oh, they ran out. They ran out of all the bits.
Yeah.
So that's annoying. It was a great deal while it lasted. If you didn't have Battlefield 3 yet, you could have pre-ordered Mass Effect 3. Maybe they'll go back on it with all the negative kind of publicity they've been getting on it. I, for one, am not 100% sure if that will be the case, but it's possible. The next story we're going to look at is Intel may delay shipments of Ivy Bridge processors. This is it's bad news for anybody that maybe had been kind of waiting. They were in that upgrade time. They didn't want to get a Sandy Bridge part. They were going to wait for Ivy Bridge. According to a story over at Digitimes, it is saying that Intel will start to trickle out Ivy Bridge at its expected time in early April, but will hold off on kind of the full major shipments until after June. The reason for this, according to the report, is that there's too much Sandy Bridge left out there. There's partners have a lot of Sandy Bridge processors in notebooks and in systems. Vendors have a lot of stuff for sale still. And I kind of say in the little news bit here that what's unfortunate here is that this is what happens when you don't have a strong competitor in the processor market. AMD is not very competitive in the high end, and the Sandy, the the i7 2600K and those types of things, with Bulldozer, with the FX series. And because of that, at least I think partially, at the very least partially, because of that, Intel sees no need to push out their new architecture. And even if you look in the notebook space, because really Ivy Bridge is not a big CPU upgrade, it's a big GPU upgrade. It's a big mobility GPU upgrade. And you do get a lot of power improvements on the CPU side of things. So for the notebook view, it's much more important than it is on the desktop view. So what does this mean? They're saying that you'll see trickling out of the parts in April, full shipments after June. So my guess is you'll see, maybe new Macs, certain notebooks come out with Ivy Bridge, but you're not going to get the majority of stuff till after that. Josh, you have any thoughts on this, on whether or not you think the competition plays a specific role, or is it really more of a financial thing? It's obviously not a technology thing, which is what bothers me as an enthusiast and as a member of the media who wants to see these things progress. It's obviously not technology holding them back. It's either business reasons or competition reasons. What are your thoughts?
I think it's multiple things. I think that Intel was maybe a little bit too optimistic on their 22 nanometer process. I know that they had some initial really good results, but I believe when they started going to mass manufacturing of these products, they probably ran into a few problems, and that's to be expected. They're dealing with a lot of new technology at the 22 nanometer node, and they could push it out if they wanted to, but again, we're not expecting to see the AMD Trinity until late Q2, which is probably when Intel will start pushing out more of the Ivy Bridge. They've been able to, the 32 nanometer manufacturing, which is what Sandy Bridge is based off of, has just been going gangbusters. It's very mature. They've got a huge amount of products out there, and they all just run like they're supposed to. And so Intel is hoping to keep their manufacturing lines going at full speed until they can transfer and ramp up 22 nanometer to where they're going to be. And I think that they just plain have a lot of product out there. And so, a couple extra months, they can chop that back, and partners can start getting rid of the products. And I think it's three different parts. It's inventory, it's manufacturing, and it's competition. And so, AMD is not competing with them. If we look back at the AMD K6 when it was released at 233 megahertz, it was the fastest processor on the planet at the time. Intel moved up the Pentium 2 launch by about 4 months, and 1 month later, AMD no longer had the fastest processor out there, even though that the Intel Pentium 2 had to use the old FX chipset, which was kind of crappy. You had to use EDO DIMMs, well, not DIMMs, but SIMs, and it just was not where most people wanted to be, because as a first adopter there, you got to miss out on SD RAM. But it's going back into old ancient history. But it's a multitude of reasons why they are probably doing this. Yes, we're going to see it in April, but we're not going to see huge amounts of it until AMD probably releases Trinity, and Intel wants to put the kibosh on that, and some of their partners have sold off some of the old Sandy Bridge stuff.
Alrighty. It's interesting. It sucks, but we'll see if it turns out to be true. And it's one of those things where they'll still be able to claim that it was released on time if it does kind of trickle out in April. Let's see. What is next on the list? We're going to talk with Alan about the possibility of VIA teaming with the company I had never heard of before, Tensilica, to roll out possibly a new SSD controller to the market. What do you think about this? Would it be something that you think would be competitive? Would it be a budget-minded part or an enterprise-minded part? Any ideas on kind of based on the rumors that have floated around?
I think they can cover the whole range with this. It's an interesting technology. It's this Tensilica company. They make a processor technology that's designed to move data around and handle I don't know that it was meant for solid state drives specifically, but it has a lot of good traits of a really good solid state drive controller, like the things that you would need if you were going to design one of these things yourself. And some of the things that a solid state drive controller has to do a lot of is it maintains a database of, when you run a read a specific sector. Well, that sector doesn't have a straight shot, one-to-one alignment with what's actually on the flash memory. It's actually like remapped. So a solid state drive has to keep a database of that. That's how it accomplishes its wear leveling, its write combining, all those things, tricks that make solid state drives fast, compared to just like a USB thumb drive, for example, that doesn't do those kind of tricks. So this thing could do those kind of lookups and that kind of database manipulation really fast, like within one clock cycle. It can do it, and it can actually, I think if I read it right, it can do like multiple lookups on one clock cycle, which is actually very good, because when you deal with native command queuing, some of the things we actually test for with our IO meter tests on any SSD benchmark that we do, there's more than one lookup happening in parallel, right? It's trying to get more than one fetch at a time, right? So if this can knock out each one of those database lookups, which is actually a lot of what takes up time for any solid state drive, it actually has to do this, right? This kind of a database thing actually is the very thing that caused the Intel X25M way back in the day. That article I wrote, sort of not really bashing on them, but saying, hey, this thing slows down over time. It had to do with that. It had to do with trying to do these database lookups and dealing with this huge database. So this is a trait that would be very good for an SSD controller. And all the rest of it just has to do with moving data around. So everything really hovers around, for SSD performance of a given drive, it's really about the controller, and then beyond that, the firmware that's on it, that's making that controller do what it does. And this looks like it could be, very good tech. The thing that we try to look for in like a higher performing solid state drive is actually something that SandForce, which you hear SandForce all over the place nowadays, they actually don't perform very well when you don't have a high queue depth, when you're not giving it a lot of heads up as to what's coming, what requests are coming. Its turnaround time is kind of slow, right? It sort of has a longish pipeline from front to back, from the time that request comes in to the time it actually gives you the data, when you compare it to some other solid state drives out there. This could potentially beat everything out there if it's done properly, just because of the way it could do a lookup so fast and knock out a lot of that computation just within one clock. So that's really good.
NVIDIA's sort of compressed themselves, haven't they? They've gone from trying to make everything to just making very certain products for very niche markets. Do you think that's the way they're going with this? Is we're looking at an SSD specifically designed for database and not for general consumption?
I don't think they would go that niche with this. Really, it doesn't matter. SandForce was originally trying to push real hard for enterprise only. Yeah. If you think back, right? But it turned out,
didn't go so well.
This is well, but it wasn't a bad thing, right? It was like, hey, this is actually a pretty darn good controller. So it just naturally, almost immediately trickled right into the consumer market. So even if they tried to push this as an enterprise only kind of thing, it would, if it performs really well and people see that, there's going to be a demand. People are going to be buying them anyway for their home stuff. And if you think about just VIA in general, they tend to produce low cost and very low power parts, right? So if they're using that same kind of technology, they take this technology, they wrap it into their process tech, they can make those low power controllers. The SandForce controller on even the Intel 520 series draws almost an amp. That's just the controller. That's kind of up there, right? Even compared to Intel's own prior generation parts, their own controller, their native one. This could do something potentially quicker than the original really low latency Intel controller, and do it at like the same or less power level if it's executed properly. So that's, there's a lot of potential there. It's, again, all we have is a simple block diagram and an announcement right now, but these are the kinds of things that turn into like a really good product potentially. Again, they got to do it right, obviously. Right. But if they can pull it off, it would be it would be something very good, especially with like the push towards ultrabooks and low power mobile devices and that sort of thing. And yeah, it has potential, definitely. It has legs.
Did you guys see the new HP Z1 Workstation? This it was just kind of announced. It'll be out, I think, later this month. This is, imagine the factor of an all-in-one PC, kind of like an iMac, but it is completely a PC inside, and the screen lifts up for you to be able to access all the components inside, CPU, GPU, power supply, that kind of stuff. If you go there, there's a video somewhere. If you look at the second image on this post, you get an idea of what is so interesting to me about this particular design. It is the capability to open up one of these all-in-one PCs very easily, upgrade components, access components, memory, discrete graphics. You basically have a discrete graphics card installed on the system. I'm not sure if it is going to be like a user replaceable graphics card where you could take something off the shelf because it is an integrated display. It's possible that there's just a DVI or DisplayPort connection internally that connects to the machine here. The workstation is expected to start at $1,899 when it ships sometime around April. It does list an Intel Core i3 and integrated HD 2000 GPU, obviously, but there's going to be discrete graphics on it for sure, probably from the NVIDIA Quadro line, specifically on this. If you look around, I don't know if we have we don't have the video on this post, but there's definitely a video that gives you an animation overview of how it opens, how it functions. And what's interesting to me is I kind of view this as a really good in-between position. People calling for the death of the PC, the death of upgradable PCs, and how notebooks are going to take over everything. And this is a good in-between. You get kind of the sleekness and the aesthetics of an iMac, but you get the upgradability and accessibility of a PC in a brand new design. I don't know. It's a pretty interesting little device. It's going to start in the workstation market where it's kind of a higher margin for them to try it out. But it's definitely pretty cool. And this would be something that I think we would integrate into our workflow. I don't know about any consumers yet at this point, but it's definitely pretty interesting. Josh, did you? Yeah, go ahead.
I just did an SSD upgrade for a friend of mine's 27-inch iMac, and that system right there is complete polar opposite as far as how easy it is to upgrade. It looks like you just pop the lid on it, and you're just changing whatever you want to change, whereas the iMac is like it requires suction cups and magnets and 5 hands. I'm not kidding. It's you
that
actually
55-gallon, container of lube to get in there. Yeah.
You and the lube, always with the lube. I know,
but NVIDIA talked about this on their quarterly report. I mean, this is something that they were really looking forward to. They think that this is an area where they can expand into. And HP is taking the first big step here with this kind of all-in-one PC/workstation, and you can upgrade the graphics to it. Now, what I'm curious about is if there's going to be kind of an external port where you can plug a second monitor into here, because how many of these workstation professionals that only works on one 24 or 27-inch monitor? I know of very, very few. I mean, I work in an engineering firm. In ArcGIS and AutoCAD, you have multiple screens because that helps your workflow a lot more. So I'm going to be curious how HP is able to market this, how successful it is, and yeah, it's easy to swap things out, but you're going to have to swap cards out and buy them from HP because I'm pretty certain that the form factors involved in here will be really specific to these type products. So I have no idea how successful it's going to be. It's an interesting thrust, but it really depends on economics and how successful it is going to be.
$1,900?
Yeah.
You like $1,900? What you get for $1,900? Oh, you get everything.
Box. Well, true.
For the workstation market, it's not entirely out of the realm. It's not a stupid expensive product based on. It will depend on what specifications it has and what Quadro GPU. Quadro GPUs tend to jack up the price of these things quite a bit. But I am asking for a review sample to try to show off some of these benefits of this particular form factor. So hopefully I'll be able to get one in. Intel released a new bit of information on something called Rosepoint, which is a new SoC. And what's interesting here is that Rosepoint looks to lower power consumption. Oh, hey, Ken, will you get me my battery, the cord for this before the machine dies? Speaking of lower power consumption, the Rosepoint SoC looks to lower power consumption by, quote, rethinking the RF transceiver and including it on the die itself. This is, I don't know if you know how significant this is, Josh. It sounded like the way they were talking about it that it was very significant. Moving the RF transceiver onto the die, getting rid of all of the analog components of the RF transceiver, and they think that this is something they've been working on for quite a few years that will drastically affect battery life, power consumption, helping them get into some of these smaller mobile markets.
Well, let me ask you this.
Mm-hmm.
If you're using 4G on your handset, how's battery life currently?
It's awful.
Yeah. And
More
this is
awful.
going to be something that will help that significantly. I mean, it's going to be, double of what you see currently, just because they're able to integrate this in lower process technology. It's better understood, better designed, and so yeah, I mean, this is going to be a very positive thing for the mobile market, especially as now we are seeing a greater proliferation of LTE, 4G, all these other higher speed bandwidth type wireless applications. And this was one of the huge power sinks of these new phones that have been coming out for the past year that have supported these technologies. So, yeah, it's going to be big. It may not be huge because we've got other guys that are going to be doing the same thing. I mean, Qualcomm, NVIDIA, whoever. I mean, they're all working on these products that are going to have the modems and these structures / chips, put on the same SoC, where they can more adequately control the power that they take off. So,
Alan, anything to add here? I don't know if you had any kind of background on the RF side of things. Is it really that power intense? I mean, you mentioned like your 4G radio taking that kind of stuff up, but I don't know if that is it.
The thing that stuck out to me is that whatever the power, I haven't researched how much power a typical Wi-Fi whatever uses, right? Obviously, any kind of anything higher than G is going to suck down more juice if it's an analog device. But the thing is that this is a Class D device. It's digital, so it's actually making the effect of an analog signal, but it's doing it digitally, just by basically fluctuating between on and off, as opposed to having in-betweens, right? Or some kind of a ladder of circuits that's just goes on and off. It's basically like digital to audio conversion on the fly. Anybody that was into car audio a few years back could recognize this as a Class D subwoofer amp. They used to make those, and they were really power efficient, right? So it's the same thing, just much smaller scale and much higher frequency. So just as applied to a chip. What's cool is that I think they can go a little further with these kind of devices moving forward if they start making them as digital class devices. Remember that white space discussion we had and things using alternate frequencies and things like that, right? When you have a digital type of a transceiver like that, there's a lot of variability in what you can transmit and receive. Frequency-wise, you can basically just reprogram it, and you're just doing something totally different, right? So that's pretty good for future stuff. For now, it's cool that it's just built into a chip. You don't have to worry about installing, that silly little Wi-Fi board in an Ultrabook, because it would already be part of the processor. So that's already taken care of, right? And just the lower power. So Ultrabooks right now, you don't see a lot of them with wireless N. for example, right? The UX31 I have here is just wireless G. So why are they doing that? Probably for power consumption. And
it's interesting. If you look at this image kind of behind me here, you can see this from the video that's embedded on the news story. Look how much die space a 2.4 gigahertz RF transceiver actually takes up. It's pretty significant. It looks like it's as much as one of the Atom cores. This first chip is going to be built on a 32 nanometer process, but they say it's easily scalable down to 22 nanometer as well, which would obviously be a pretty big benefit there. Jeremy, let's talk with you about near threshold voltage, what that really means, and kind of what Intel's research is that they've kind of been discussing recently on this. This is kind of like the exact opposite of what we normally talk about on this podcast, high performance, that type of stuff. This is talking about running processors at 3 megahertz.
Wow, 3 megahertz, that's pulling 280 millivolts. Because, hey, ARM is coming at this from the bottom. They don't suck much power, but then again, they don't provide much performance. Intel AMD, on the other hand, pretty good at sucking down the power and providing the performance. But it looks like, yet again, the Pentium architecture has been pulled out by Intel Research Group. And sitting at the 32 nanometer the 32 nanometer process, they've figured out a way to take speed step far beyond the way wherever it's been before. The thing with processors are that the faster you want them to flip, the more energy you have to be providing them. This hence being threshold power. So if there's a way that as a processor slowed its clock speed, that you could also reduce the amount of power that it's drawing, you would end up with a chip that was just unbelievably power effective. And that's exactly what they've done. They've got the clock up to 915 megahertz, pulling 1.2 volts on what most overclockers tend to refer to as VCC. It will scale down, as we started out, 3 megahertz for 280 millivolts, at which point you're no longer even needing an active heat sink. We're back at the time when the heat spreader on the CPU was pretty much good enough to 2 millivolts in sleep. And that is just ridiculously small amount of power. And the fact that they can do it on the fly, scaling it back and forth depending on the load, means that Intel now really, really has a great product for people that are energy conscious, that are running big server farms that need to pay for them and don't want to pay for the downtime. Well, if you're drawing 2 millivolts in sleep mode, you're not going to be paying anything. And, you know, it also goes to show just how versatile this Pentium architecture actually is. Hopefully, though, it doesn't follow the tradition that several other recent Pentium rebuilds we've seen have had happen to them. See you, Larrabee. And the other thing that was worth mentioning along with that was that we've all heard they built a working transistor out of a single atom. Of course, the trick is you got to get it down to negative 192 Celsius to be able to stop moving the bloody atom more than 10 nanometers, because at that point you can't really predict its position well enough to be able to use it as a quantum computer. But hey, a little phosphorus atom, if you're keeping track, 0.110 of a nanometer, is now considered actually a working transistor. Could be fun, but I think we're going to be seeing the rebuilt power consumption from Intel first.
Yeah. There was another announcement from the ICCS. That's not it. Maybe there's that. There it is. AMD and Cyclos reducing clock power usage with pile driver, which could be important for AMD if it wants to help get clock speeds up and performance per watt up in that regard as well. Josh, tell me a little bit about what a resonant clock mesh is.
Well, hopefully I won't make this too much of a disaster.
Okay.
But essentially, when first we're chips were first designed, you could propagate a clock signal very, very easily. As designs became more complex, more transistors, much larger, even though design size kept shrinking, it was still complex to propagate the clock signal and distribute power throughout the entire chip. Well, it was starting to become a pretty major issue when we're starting to deal with billions and billions of transistors like we are now. If you think about it, if you only had kind of the clock propagation happening at the beginning of the chip and it goes throughout, I mean, you've got synchronization issues, you've got power issues because you've got to have a really, really strong signal at the beginning, and they've done trees to kind of help that out, but they've become ineffective and in the past 10 years, and these cyclist people who used to, I think, be part of Michigan State or University of Michigan, I can't remember which, they have developed a way to kind of trap the energy in these clock propagation measures and able to kind of recycle it, and it does two things. One, less energy is put in per clock, so you have lower heat and lower power consumption, and it also keeps everything synchronous and as they're supposed to be. Now, Alan can jump in anytime and correct me, but essentially what happens is they have a series of capacitors and some clever design things in there to allow it to kind of power up at the beginning, and then every time it needs to have a clock pulse. It just kind of nudges it at the beginning, and it distributes through there, and everything fires off, and then the energy and power that was in there is, again, taken up by the capacitors in there. And, of course, I'm not an electrical engineer, which is very obvious from the way I'm talking.
I got a simple analogy.
Let's hear it, Alan.
It's sort of rough and just shoot from the hip, but like if you had a room full of tuning forks, and they were all the same frequency, tuning forks. If you were able to ring one at one side of the room, and you did it for a little while, then over time, in theory, all the tuning forks would start moving at the same time. They'd all be in sync with each other, roughly, right? And then if you stopped, you're only adding a little bit of energy to each one, but since it's a resonance, you don't have to drive it at full power, right? Compared to a typical a regular clock signal that has to propagate across the whole CPU, there's an enormous power demand every time that signal tries to change state, right? Because it's trying to change state, but that state change goes to the input of I think it would work out to roughly half of the transistors on the entire chip, right? Maybe a little bit less depending on how the flip-flops are designed on the thing, how the actual circuits that change state are designed, but the clock goes everywhere, right? I mean, everything is synchronized on it. So, it's just this huge power draw, this huge headache trying to get it to go everywhere. And if there is something where you have to dump current into something, it actually takes time for those electrons to shift over and change that voltage at the different locations, right? So that's the whole propagation part of it. So because of that, you would end up with a ripple, right? It actually takes it. It's not necessarily changing at the speed of light, even. Which is theoretically how long it would take. It actually takes longer because it has to build up a voltage at the different stages of the chip as it goes from where the source is across and propagates across the chip. So the problem is that those other signals that are trying to get around the chip, they can move much faster because they don't have to worry about fanning out to a million different directions. Right, they're just going from one transistor right to another one. So, yeah, you end up with what Josh was talking about, which is where the one signal is actually going really fast, but the clock hasn't even made it there yet, and then you end up with, having to deal with all these kind of synchronization issues and everything else. So if you're able to make a circuit that can different pools of energy basically around the chip, that and it's actually called a resonant tank circuit for electronics folks, but you're just adding a little pulse of energy to it every time it's supposed to go on its upswing. So it'll keep dealing with divvying out that current to its little subsection that it's powering, and you won't have to worry about this huge, huge chunk of current coming from just one source and trying to fan out to everything. It's basically like little power substations for the clock they're actually their own clock, but they just all stay synchronized off of this pulse coming from like the source one. It's kind of a hard thing to explain.
It's complex, yeah. I don't know.
But it's much more efficient, and they promise anywhere from 5% to 30% better efficiency because these fan outs and the clock signal. I mean, we're talking about just billions of transistors that they're trying to kind of activate in there and areas that it just became too much. And so, yeah, this is kind of going back to Allen and the NAND. It's a better way of doing things without hitting the wall.
Yep, there you go. And I see. I don't know exactly how they're implementing this. I mean, we only have like the theory from the press, like one press picture and with a really rudimentary circuit drawing. But my concern on this is this might be limited to which kind of processors you put it in, because if it's tuned to a specific kind of frequency, this might conflict with people that like to overclock a bunch, right? Because the higher you overclock it, now these circuits that were tuned to resonate at a certain frequency, probably something close to what the clock speed is, like the default clock speed, right? You'd have a harder time ramping up the frequency, right? Because now you're working against the very thing that was helping you in the first place. That a circuit like that has a resonance in it, so that it only has a certain band, right? It's almost like a filter effect in some ways. So if you go too high out of that band, it's actually going to work against you more than even if you didn't have that circuit in the first place. And the same sort of thing would happen if you turn down the frequency too far. So that makes me wonder, like, is this really meant for... Yes, it'll save power, but if you put it in a mobile platform, is that mobile platform going to be stuck at a fixed frequency versus being able to downclock a whole bunch when it wants to go to, some kind of a lower power mode? So I don't know. I mean, they might do some tricks to it. You can make a circuit like that that's tuned for different frequencies just based on like one simple extra transistor changing some part of that circuit, but you would have to reproduce that change across the entire, all those substations on the chip that are doing that. And you basically have to change tuning on the fly. So it gets really complicated, right? I mean, it's a nice thing, but just like all nice, what you would think is elegant additions to a technology, it gets really complicated when you try to add in, all the other features that you're used to, like being able to dynamically change clock speeds and stuff.
All right. One other bit of news we want to get to before we get to our picks and that kind of stuff for the show is the information that Intel is, in some capacity at least, going to become a foundry to outside parties, in particular on the 22-nanometer process. They announced that they will become a foundry for customers looking to manufacture chips using Intel's 22-nanometer process with tri-gate transistors. Current competitors in this industry already include TSMC, IBM, Samsung, Global Foundries, etc., etc. Only 2 customers of Intel's process have since gone public with their foundry choice. Achronix Semiconductor manufactures field programmable gate arrays for users to install in their products to give them basic logic functions. And Tabula, who also designs FPGAs, has specifically announced that they will begin using 22-nanometer process. Now, they didn't announce anything super out of this world like NVIDIA is going to use us or anything like that. But do you think this changes the landscape in any way, Josh, in any kind of significant way right away?
Not really, because Intel does not do any kind of FPGA work. It really is a niche market. And we have several large companies that do FPGAs. And certainly they are useful in a variety of applications, but Intel so far is not interested in that. And so it doesn't hurt them to offer these guys foundry space because Intel can only, they produce a lot of chips a year. In between the 32-nanometer process and their upcoming 22-nanometer process, the last thing they want to do is to either, 1, oversupply the market and drop down the price, or 2, leave their fabs idle at times, which neither are very good for Intel. And so they're looking at the current market, and it has been down because of the whole hard drive shortage. And so to kind of make that up, they're offering a little foundry space to some of these guys in an area where Intel does not compete, nor really seems to have any interest whatsoever in competing. So they're keeping their fabs productive. They're getting income from that, from other guys, and they're not oversupplying the market with their own products based on the 22 nanometer process node.
Do you not see this as just like the first step into allowing all these other companies to utilize their foundries to build their own chips?
I don't. I see this more as a stopgap measure, because eventually Intel is going to want to use their 22 nanometer process to do more mobile applications with their own processors and own designs. They're just kind of pushing this in there to make sure that they continue to make money. Their margins are continuing to be high.
Yep.
But
and somebody else gets to play with their process and see what goes wrong.
Yeah,
and gets to pay them for the privilege of it.
Yeah, exactly. And so, I mean, you know, this is all money coming into Intel. It's not hurting their market share because they don't have an FPGA that competes with these people. And so, you know, if
I guess I'm not worried about
said,
Intel.
hey, we want to use their 22 nanometer process, Intel's going to cut them off and say, no, are you effing crazy? No, it's not going to happen. I mean, this is really the only way that Intel is going to become a foundry for somebody else, is if they have a product that Intel does not directly compete with them with.
But there's a lot of those products, right? I don't think Intel would manufacture ARM processors. That would be dumb. They don't want to give their advantage.
But they will manufacture Atom processors that will compete against ARM. So yeah, we're not going to see ARM in there.
For third-party companies.
But FPGAs. And Intel also, didn't they buy a modem company? Didn't they buy some, you know, Infineon's mobile space, and they're putting that technology on there? So this is another area where, you know, Intel is I mean, they're not going to offer foundry space for these kind of guys that are going to compete directly against them unless they're really, really, you know, Machiavellian about it. Which
FPGAs are pretty much like as close to a polar opposite as you can get compared to a regular clock-driven CPU. You know, the only common thing there is that it has to be manufactured on dies, really, on wafers. Yeah. So yeah, I mean, they're playing it safe, right? It's definitely a non-competitive thing, and it's being able to make FPGA tech. FPGAs are used basically it's just a purpose-built. I don't even want to call it a CPU. It's just purpose-built logic. Right? It's a logic array, but if you can make logic arrays like that on 22 nanometer, you can make them do a lot of things, right? Because you could fit a lot of gates onto
breadboards. Just got way more interesting.
Yeah,
I mean, you could do
little LED adders I made in high school. So awesome.
You can do high-end crypto, like really high-end crypto routines, really really fast with something like that. I mean, we're talking like orders of magnitude faster than any CPU would hope to ever get to. So. What I'm wondering might come from this is if Intel's partnering up sort of with these guys, or they're making chips at their fab, at some point in the future, I could sort of see like Intel taking a look at. I mean, they're making it at their fab, right? So they're obviously going to see what kind of stuff's getting made, and there's just I'm way out there theorizing here, but if I was in their shoes and I saw this kind of stuff, perhaps I might make some instructions or add some I want to add some of those instructions or add some of those features as a form of an instruction set as a part of a processor tech, like an advancement in processor tech in the future, right?
They would just buy them.
But how do you know which is the best guy to buy? Well, guess what? We're making it all for everybody. So let's just look at all their, which one looks the best. Oh, okay, these guys are really good at what they do. All right, these guys that we acquire, and then now we're just making chips with an extra as a SIMmed instruction set, whatever that has to do with crypto, right?
Yeah, and to just kind of give you an idea of what FPGAs do and how they do it, NVIDIA, AMD guys that do these graphics, I mean, they use FPGAs to simulate their processors and how data moves through them. And while the latest and greatest GPUs run at 800 to 900 megahertz, these FPGAs that they're doing tests on are running at 500 kilohertz. I mean, 5 megahertz rather, or whatever. But it's it's a huge magnitude. It's an order, several orders of magnitude slower for these FPGAs. And so it's not like, hey, we got a 22 nanometer FPGA. We're going to take over the ARM market because we can, program them to do these things, and we can do it cheaply, and it just goes from there. But no, I mean, there are some basic physics behind FPGAs that they just are not competitive in these, going against these ASICs, ASIC marketplace, CPUs, GPUs, whatever.
Yep.
All right. Before we get into our picks of the week, which we'll run through, another quick reminder: if you missed the beginning of the show, I don't know how you got here, but PCPer.com/contest. Go there. There's a contest to win a completely outfitted Sandy Bridge E-based computer from our friends at Intel and PC Audio Labs. Go to PCPer.com/contest and check that out. Really easy to enter. You've got until, I think, March 5th to do so, but might as well enter now and get that out of the way. So, with that in mind, we will jump to our hardware, software picks of the week. And it was busy week for us, so I've actually got a couple of them here. The first thing, if we switch over to this camera, you'll see, first of all, my Intel bobblehead guy that I found again that I thought was pretty cool. The next thing you're looking at here is an LED kit from IKEA called the Dioder, or however you pronounce it in IKEA language. And what's interesting here is that you get these little strips of LEDs, and you just simply connect them up, and boom, you've got LED lights. And what's cool about this is with this connector, you can actually manually control the color through this color wheel. So if you want them to be white, you can make them white. If you want to make them yellow, you can make them yellow, green, all the way through the RGB scale there. It's actually pretty cool. And what's interesting is that it's very expandable, at least in a certain bit, that you just add on more strips. And the reason
you'd put those like behind a cabinet or to light up the wall, like around the perimeter of something, or.
So we were actually looking into this as part of our upcoming set redesign, and we liked these because they're from IKEA, so they're relatively inexpensive. This package included 4 of these LED strips, and then the controller can actually power all 4 of them off of one connection, or you've got 4 connections, so if you wanted them to kind of spray out. The problem is we haven't been able to find these units individually to kind of expand outside of the 4 that we bought. Like this set is $40 from IKEA, and you could get 4 of them that way. We need probably, I don't know, whatever 8 feet times 25 or so is worth of these LEDs, so we don't want to have to spend $40 every time we do so. But you can see like the whole color combination thing is really nice. You've got the ability to you can have it do this quick cycle through all the colors, or you can have it flip through the colors. It's pretty nice. It's, I don't want to say it's high quality, but it's decent quality for $40 for this. And we'd like to be able to find these without having to buy.
They say the expansion LED bars on Newegg are $6.99 a piece.
Ouch. It's still cheaper than 40 for 4.
Yeah, that's true. Okay,
just by a wee bit.
And Alan, did you make your purchase? Because I'm going to give the second hardware pick.
I'm gonna.
It's too late. I give up.
Go ahead. It's gonna
so
be gone.
this is actually Ken's hardware pick of the week, and this is what Ken spends money on. You can see here we have. This is what's cool about this. See the name of it? What's it say? It says
Superboy.
Superboy. And this is a Super Nintendo hardware. Like, it's not an emulator. It is literally a Super Nintendo. And this
Do you
is
still have to blow on the cartridges to make them work?
Yeah, we actually had that joke earlier, too. Alan, yes, we do have to do that. So, it's very hard to
you
play
did?
this.
You actually did have to blow on the cartridge?
No, we didn't.
It's not like they're new now. They've been around for a while.
Actually, that's why Ryan was commenting earlier. We were talking about this, that it's really hard to pull out the cartridge. That's because they actually made the connector like a decent connector. So, yes, in theory, you would not have to.
This is for
cartridge.
sale on Amazon. Keep in mind, for $80, not with the game, of course, but for $80, you can get a Super Nintendo and a handheld system. It does use batteries. It's like a cell phone battery of some kind. Ken was saying, rechargeable. They say the battery life's 3 hours or something. Not very good, but it does have DC input if you want to use that. It's got AV out, so you can hook it up to a TV if you want. It's got integrated speakers. It's got controller inputs, volume bar, headphone bar. It's pretty cool. I bought one when he showed this. And
How
it's
much
really
were they?
$80.
That's
$79. Yeah, and depending on what games you want, be prepared to pay. Like I wanted a copy of Final Fantasy III. It's probably going to cost you like $60 or $70 used. That's why ROMs are awesome. But this is cool to see. I don't know how long this will exist on Amazon, so you may want to buy it right away. We're debating whether or not this is even legal, but it's pretty sweet nonetheless. And then the last thing I just had to show you guys on this. I don't know if you saw this, Burke. If you added it into the show notes, I can't zoom in enough. This is an engagement ring that somebody posted on Google Plus.
That's awesome.
Isn't
It's
that badass?
Perfect.
Well, for our audio listeners,
It's a transformer.
Yeah, it's a transformer.
This will turn into a divorce suit.
transforms
Nice.
into a divorce.
It's a ring. If you look at the profile of it, it is the Transformer logo, or is that the Decepticon logo? That's the Decepticon, isn't it? Yeah. Holding the diamond on it. So that's pretty awesome. Somebody in the chat room said that would be Colleen's engagement ring. That would fit. That would fit pretty well. So that's awesome. Those are my picks, mine and Ken's, I guess. So, Jeremy, what do you got for us?
Wow, some nice updates on the hardware leaderboard this month. After chatting with Alan, he convinced me that, you know what, 3 of the 4 systems have to have SSDs.
They're all
And
doomed
it's nice.
now, though.
Well, of
They're all
course, yes.
doomed.
I mean, your bits are running out. As we speak, your bits are disappearing. I'm doing this on an SSD. I'm going to be gone any second now. But it ranges from the brand new Intel 520 series for the Dream system down to a nice Samsung 830 series, 256 gig for the high end. And even the mid-range got to keep one. It's 128 gig OCZ Octane. All 3 of those are SATA 6 gigabits. And all the boards are SATA 6 gigabits. So if you haven't played with SSDs at full speed, because it does make a difference, I definitely recommend taking a look at it, even if you're not just building a new system, if you're looking for an upgrade. And the other really nice thing is Zotac, the AMP series, that ridiculously overclocked GTX 560 is back, except it's a titanium edition this time. So you get a couple extra processor cores, and you pay, after the stupid mail-in rebate, $5 extra than you would from the vanilla version. So check it out if you haven't in a while. Some stuff hasn't changed because Intel isn't putting out new processors, but some of the other components have. See, look, I'm getting darker. My SSD, it's dying. It's dying.
Oh, no.
He's going to go all 300 on you.
His bits are fading.
Nice. Josh, what do you have for us that's gone?
Going, gone. The Asus EAH6850 for about $159. Then minus some rebates, like $129, something like that. It's a good card. I just tested it. I'm going to have a review on it here shortly. If you're at that price range, that's a fantastic bargain. It runs very, very quiet. You can overclock nicely. Your packets won't be intercepted at the border.
Here's what's depressing about that. We talked about this, I guess, last week with the 7770. That's the exact same price as the 7770.
But it's
and
faster.
That's a better card, and it comes with Dirt 3.
Yeah, Dirt 3, which is still a $49 game or something like that. You're good to go. Get it. while you can. Undelayed.
All right, Alan, round it up for us, or round it
I'm
out.
gonna
Do
counter.
something.
I'm gonna counter Ken's pick
Okay.
with, and I noticed it was a Nintendo device that has a D-pad on it. So, in case you're combing eBay and feeling retro-ish, look for one of these. Donkey Kong, Game & Watch. Yeah, I know, you guys are giggling. Guess what? This thing is the first thing that ever had a D-pad on it.
Mm-hmm. It is.
The first. This is where the D-pad came from, people.
Looks like a Game Boy to me.
Up, up, down, down, left,
Oh
right,
no, it
left,
was
right
before
would not
Game Boy
happen.
Spinach.
That was Konami.
Yeah.
This
You
is
can't
before
use that.
Game Boy Spinach.
So that's 1982, by the way.
Ken, how old were you in 1982?
I happened to... I don't know. How old was I in 1982?
Ken was -10 when
I
that
was
came
like,
out, Alan.
I was like 7 or something. Yeah, Ken was there. I got one of these for Christmas when they first came out there, Ken, so get off my lawn. This is not the one that I had. That one's since long gone. I have no idea where it went, but I was feeling like nostalgic one day and combed eBay and found one of these guys. Still works when I put the batteries in it. It's pretty awesome. But yes, it's old school. Like the little Mario guy has like different LCD segments for each place that he is on the screen.
Hell yeah.
And they light up individually. And the color, it is color, but it's only color because, and actually this is not even on at the moment, so they just like painted the LCD plastic.
Yeah, those were the best games.
Yeah, and they light up.
It just like,
Actually, they suck.
and it's two display, right? Notice there's a ribbon cable between the two so that they can be hinged and not break. And if you break this ribbon cable, like I did when I was a kid, the top screen doesn't work anymore. Just saying.
Pretty
Cool stuff.
awesome stuff. So we're a PC hardware show. We gave you a hack together, probably illegal Super Nintendo, and a game. So thanks,
Well, we
Jeremy
should
and Josh,
give
for
the
keeping us
illegal
legit.
Pokemon.
I had to
Yeah.
spend as much. I had to spend as much on eBay for this guy as Ken got the Super Nintendo for. So he's got me beat on that.
Do you feel maybe a
They're
little
hard to
silly
find.
about that?
They're hard to find. If you want to get the bouncing baby one, the original bouncing baby one, it goes for like several $100. I gave up. It's too rich for my blood. I want it.
Yeah, no
but
doubt.
Yeah.
All right, that's going to do it for this week. 1-888-38 PC-PER. We still have a toll-free number if you want to call in and leave us a message. Podcast@pcper.com is the email address to give us your feedback, your thoughts on the Superboy, or anything else, I guess, for that matter. And, of course, pcper.com/podcast. And anybody who's listening, I would encourage you to check out youtube.com/pcper. We post all of our videos there. We're always looking for feedback on the styles that we use, the quality that we have. If you have any thoughts about our videos there, you can email me directly, Ryan@pcper.com, or you can email the podcast for that as well. YouTube.com/pcper is the site for that. Go there, subscribe. Let us know what you think about the videos. We're going to do a lot more stuff in the video world very soon, hence the kind of changing area around us in the 500-foot Ethernet cable of wisdom, as I like to call it. So check that out. Let us know. We're always eager to know what you guys think about our projects. So that's going to be it for this week. We will see you in 7 more days for more hilarity and PC hardware news. I'm Ryan Shrout.
I'm Jeremy Hellstrom.
I'm Josh Walrath.
And I'm Alan Malventano.
Thanks for listening.